What is the sound of the sun like? It's a straightforward question with an equally straightforward answer. Of course, the sun is silent. Because sound does not travel in a vacuum, the sun appears to us as nothing at all. But let us abandon simple solutions. What if sound could actually travel through space? What would we hear if there wasn't a massive cosmic muffler between us and our nearest star? Would the sun sing us a beautiful melody in the sky, or would its roar be such a cataclysmic cacophony that it would be the last thing we heard? Scientists have discovered the solution. They can detect the types of pressure waves and particles released by the sun using spacecraft like the Parker probe, which is presently on skimming orbits around the sun, and translate those waves into the sounds humans might hear if space was capable of such propagation. Surprisingly, not all of the sun's sounds are the same. Hello and welcome to Z. Join me today as we listen to numerous different sounds emitted by the sun that have been recreated through ingenious science. Because it turns out that these sounds may help scientists unravel two of the sun's most perplexing mysteries. In our fictitious situation, where space has unexpectedly acquired the power to propagate sound, we can now begin listening to the sun from the Earth. Although the Earth is 151.9 million kilometers distant from the sun on average, it may come as no surprise that the sun is incredibly loud, clearly heard from where we are. This is what it would sound like. Just a friendly reminder that there is no sound in space. This is a sound reconstruction, in which amplitudes and frequencies are converted into sound waves, then snippets of what the waves may sound like to the human ear if an atmosphere were present are created. This relaxing buzz has an almost electrical quality to it. It reminds me of generators, or even something somewhat radioactive, which is appropriate given that we're talking about the sun. The nuclear fusion inside the sun creates 3.85 by 1026 watts per second, which is approximately 1,000,000 times more than what humanity produces in a full year. All of this created power has an unavoidable knock-on impact on the level of sound produced by the sun. To get a flavor of what this would be like, connect the device you're watching this onto the speakers used at your next rock performance. Then play this noise at high volume. I'm confident they won't mind. This sound level, at 110 dB, is bearable for short periods of time, but would certainly result in the whole population of the Earth going deaf if they weren't wearing earplugs while it plays in our sky nonstop. In reality, we should consider ourselves quite fortunate that we do not have to deal with this. Hearing would have been useless to species that evolved without ears. As we travel closer to the sun's surface, the sound level increases rapidly, reaching 270 decibels according to some specialists. Remember that decibels are a logarithmic scale, so for every 10 dB increase, multiply the sound level by 10. To give you an idea of how loud this would be, 270 dB is louder than our atmosphere can physically express. The Earth's atmosphere has a volume cap of 190 dB. Other media have various volume caps due to certain complicated oddities of wave amplitude and energy levels that we won't delve into here. The volume of the sun is 100 million times more than this limit. The sun makes a lot of noise. That's a shame, because some of the sun's sounds can only be distinguished when we enter that ear-splitting zone. By the time the sun's cacophony reaches us, many of its noises have merged into one, allowing us to lose out on some of its interesting complexities. To obtain a better look at the sun, we have to get closer into that blisteringly loud zone of noise. So, for the time being, ignore the sun's volume and instead concentrate on its musical patterns. If we were to enter a spacecraft and travel towards the sun, we would immediately notice a difference in the homogeneity of the sound. Instead of a steady buzzing, we'd hear something like this. The solar wind is making this sound. The sun constantly emits a torrent of charged particles that explodes out across the solar system, and its existence is one of the sun's greatest mysteries to date. It's tempting to imagine this stream beginning inside the sun and rushing outward under the immense force of all that nuclear fusion. However, by the 1960s, a significant observational discovery had been discovered. Although particles within the sun's atmosphere, or corona, moved at an average speed of 145 meters per second, particles outside the corona moved at 618 meters per second. This meant that particles with enough speed to escape from the sun's surface were floating into space, and then something in the sun's corona was hyperaccelerating them from subsonic to supersonic speeds, allowing them to be fired off. What procedure or mechanism is responsible for this is still unknown. The corona also includes a second mystery. It's way too hot. Although you might assume the sun's core to be the warmest portion of it, with temperatures steadily decreasing as you move away from it, this is no longer the case once you enter the corona. The average temperature of the sun's surface is 5,600 degrees Celsius or 9,930 degrees Fahrenheit, but within a few kilometers, the corona suddenly sees temperatures rise to as high as 2 million degrees Celsius. Something in the sun's corona is flinging solar wind into space, and something is heating things up. Scientists are also unsure why this is happening, though it is assumed to be related to magnetic fields. The third sound of our tour of the sun would be encountered here. As our spaceship approached and crossed the border between the corona and empty space known in science as the Alfvén surface, we began to hear the following. These are referred to as Langmuir waves. They are created by tiny oscillations of plasma particles vibrated by light as they stream from the sun through tiny funnels on the sun's surface, a magnetic equivalent to the sound of a kettle boiling. We have entered one of these streams. Countless streams shoot forth from the sun's surface. The sun's surface is coated in heated material rising from the star's core. Once there, the material cools and sinks back into the star's mass along the island's boundaries, and something about this rising and falling material, or something happening within the sun itself, causes these sinking zones to emit tremendous magnetic field lines. The magnetic force scoops up plasma and sends it flowing out into space. This is where the solar wind begins. Scientists aren't sure what triggers this process, but the sound of Langmuir waves is eerie. As the winds blow, not all of the waves form travel at the same speed. This has the effect of dispersing sounds because quicker parts of the wave run ahead while slower elements of the wave fall behind, resulting in dispersive waves. Such waves are packed with chirps. Little eddies of sound formed when fast waves from behind collide with slow waves already traveling ahead. This eventually settles into the hum we heard at the start. There is one more sound that may provide some insight into the entire mystery. One has intriguing ramifications. We can finally find Whistler mode waves here, right within the sun's boiling corona. Whistler waves are the distant echo of high-energy events that ring through the magnetosphere of a celestial body. We acquire them here on Earth. When lightning strikes, it produces more than simply thunder. If you have the correct detectors, you can detect a ripple traveling through the planet's magnetosphere from kilometers away. To properly grasp the magnitude of these waves, listen to what they sound like on Earth. Just a couple little crackles and whistles. Nothing out of the ordinary. Now listen to how they sound on the sun. Going from sparse, fleeting clicks to a cacophony of wailing wind implies that the sun's magnetosphere is experiencing more than just the occasional crack of lightning. Something is going on all the time, blending separate moments into one continuous clamor. Scientists are still attempting to figure out what is causing the roaring. However, one idea for the force behind this sound, which can explain the tremendous acceleration and superheating of particles within the corona, is a dry-sounding process known as magnetic reconnection. Magnetic reconnection appears to be rather innocuous, but its pleasant, technical-sounding word conceals a calamity. Because of all that swirling plasma within its center, the sun is a tensely wound-up ball of shifting magnetic field lines. I cannot emphasize how effective these are. When magnetic field lines go away from the sun, they can sometimes mix with other field lines, forming some of those iconic loops that you've probably seen in photos of the sun before. When such arcs are produced, though, all hell breaks loose. When two parallel lines intersect, a huge realignment in the polarity of the excess field lines occurs. Everything above the arc must find a new location to guarantee magnetic equilibrium is maintained. Cut loose from their bonds, the field lines further out from the sun form their own arc, which eventually catapults off into space like a massive stretched rubber band. A nanoflare is a rapidly accelerating magnetic force that indirectly heats the corona above it to millions of degrees in seconds. Scientists have only recently discovered the ability to observe nanoflares, and they aren't totally positive the nanoflares they've seen are the hypothesized occurrences they were expecting, despite the fact that they appear to be followed by the expected superheating. This is a hypothesis that is still being developed. Much of it is still unknown. Even so, it's not entirely implausible that such occasions when the sun becomes so tense that it snaps explain why its corona is as hot as it is, and why it's blasting solar winds out throughout the solar system with the force we see. To explain for the continual solar wind going outwards in all directions from the sun, nanoflares, or whatever the power behind this phenomenon is, must be incredibly prevalent over the whole corona. The sun still holds many secrets. The Parker Solar Probe, which recorded many of these sounds, is continuing its voyage around the sun, gaining crucial data with each pass. The Parker Probe is only 4 years into its 7-year mission, so there should be plenty more data for scientists to sift through. Maybe they'll have more sounds for us, each one a hint to the age-old mystery of how the cosmos works. Because, like listening to the ticking of a clock to find out how the clockwork works, the secrets of the sun may one day be solved by what we hear rather than what we see. Alright everyone, here's where the video ends. Thanks for watching and don't forget to like, share and subscribe.